Hey guys! Today's video is on systems of linear equations with two variables. So right here I just drew up two lines and I'm gonna explain a bit of how they work. So this line right here is y is equal to x plus 4, and then this one here is y is equal to negative 2x plus 10. And you can see that they intersect at that point right there. And so when we think about what that point could possibly be, we know it has to be a point that can plug into both this one and it, still remain in equality. And those same exact values have to plug into this point and it has to remain in, in equality. It has to actually plug in. So when we think about this, we're really asking what x and y value goes into both of these. So right now, we have y is equal to x plus 4 and y is equal to negative 2x plus 10. But our y variable is staying the same, right? So if we want to figure out what x variable this is, whatever this could be, all you have to do really is set these two equal to each other. Because if y is equal to something, and then y is also equal to something else, then those two things are equals to each other. It's, if A equals B and B equals C, then A equals C, right? So this is going to be this x plus 4, which again is equal to y, which is equal to this negative 2x plus 10. And then you can solve that way. Now, there are a lot of other ways of solving, but I feel like this one is pretty, good for thinking about it at first. Another example I can give is like, if this is, and after you do this, by the way, it's 2, 6, and you can go through and verify that. But, like, let's say I put a vertical line here, and let's just say that that's, x is equal to negative 3. So then, now we want to figure out what the y value would be for this thing to see where these points intersect. So we would plug in this x equals negative 3 to this x, right? So this is going to be y is equal to this x, negative 3 plus 4. And that's going to be y is equal to 1. So we know that this point right here is going to be negative 3, right? Because that was literally our equation, is x is equal to negative 3. We don't have anything other than that. So it's negative 3, comma, 1, because that's what we got when we plugged it into this equation, which again, they're intersecting. Alright, and so there are multiple ways of solving this for the variables x and y, other than the way I just showed you. Obviously, you can say, well, y is equal to this, and y is also equal to that, and thus, by the transitive property, or whatever it is, this is equal to that. You can get x and plug it back in to solve for y. That's totally fine. But there are other ways of doing it. There is elimination and substitution. I'm going to teach substitution first just because I think it's a little bit easier to wrap your head around at first, and then I'll go into, elimination. So, okay. What we have here is if y is equal to x plus 4, we can also say that x is equal to y minus 4. It's the same thing, just subtracted 4 from both sides. So now what we can do is, instead of substituting this thing, this x plus 4 in for this y, we can substitute this in for this x, right? It's literally, it's literally what we just did before. It's the exact same thing, it's just that sometimes you have to move stuff around in order to substitute it in, like I just did. So now, instead of plugging, this in for y, we're going to plug this in for x. So we have negative 2, and instead of plugging this in, again, we're going to go times y minus 4, and again, we always put it in parentheses, because that's when you plug in something into a variable, plus 10, and that's all going to be equal to y. Okay, now we're just going to solve this. We have negative 2y plus 8 plus 10 is equal to y. We have 3y, we're just adding to y on this side, is equal to 18, and lo and behold, we get y is equal to 6, just like before, and thus x is going to be equal to 2. Alright, so this method is called elimination. And it's all centered around this property. So a equals b, c equals d, thus a plus c is equal to b plus d. And a really easy way to kind of get your head around this is like, okay, what if we had, x is equal to y plus 5? Well, if you subtracted 5 from both sides, right, then the equation's going to be the same. It's going to be equal to each other because you're doing the same thing on both sides. That's exactly what this is. This plus c is basically just minus 5 on both sides. You're just doing the same thing to both sides is all that's saying. So how we can apply that to this is that we can say, well, if, we say, we're just making stuff if this is A and that's B and then this is C and D, then we can say, oh, well, A, Y, plus C, Y, is equal to x plus 4 plus negative 2x plus 10. But how does this help us? It's because we can manipulate these equations, these ones here, to get certain stuff to cancel out, right? Like, if we just made this whole equation negative or this whole equation negative and then combined it like that, these y's would cancel out, right? It would be y plus a negative y. Already we've simplified for our x, right? That's pretty great. But how we can represent this a lot easier than writing it all out like that is literally just changing one of these equations and then going like this and adding it just up and down because it's the same thing, right? You're adding these two and you're adding these two. That's all it is. But instead of just changing y to be a negative, which you totally can do and solve it, I'm just going to show you something else that happens a lot that you're going to have to do probably a lot. That's a little bit trickier, but not really. So let's say instead of wanting to cancel out the y's, we want to cancel out the x's, right? Well, how are we going to do that? We need to make sure that when we add these two things, these x terms need to cancel out as well. So we need to ask ourselves, okay, what can we multiply maybe one or both of these by so that the x terms cancel out or add up to 0? That's what I mean by cancel out. So, well, we can divide this whole thing basically by 2, right? Then we would get y over 2 is equal to negative x plus 5, which is fine. We could cancel out the x's, right? It would be x plus a negative x, which cancels out to 0. Or we can multiply this whole thing by 2. And I would rather do that so we don't have to deal with fractions. But again, you can do whatever. And we're multiplying this whole thing by 2, right? Because whatever you do on this side, you have to do on this side as well. So this is 2 times y, and then we're just going to distribute it over there too. So I'm going to rewrite it. 2y is equal to 2x plus 8, right? Because you're multiplying everything over here by 2. Okay, 2y is equal to that. And then now we're just going to rewrite our other equation. And now we can solve this really easily, right? Can cancel this out. This is going to get us to 3y, right? Because you're adding these. And then this is going to get us to 18. And oh look, it's the same exact thing answer as the other time. So it's just how we know we're doing it correctly. And again, you could have done it starting with just make this whole thing negative or whatever with the y's. But a lot of times you have to multiply it by some number. It's support. And, and yeah. So I lied in the title of this video. This is more than 2 variables. And I'm not going to try to graph it because that would be like a 4-dimensional graph. And I don't necessarily have that kind of capability. So basically, we have 4 variables, which is 2 more than 2. So it's, more unknowns. So what we want to do is start with what we do know. And thankfully, they're giving us 4 equations, though. And this is very similar to an exercise in your textbook that I got. I literally just changed up the numbers. So it'll be fun. Basically, what you want to do is start with what you do know. We know W is equal to 8. There's no funny business there. It's fine. So now what we can do is say, well, okay, what can we plug this 8 in for W, right? Just get rid of that variable. We can plug it in we can plug it in here into the equation above it, because that would make us just have one variable left, z. We could also plug it in here, but then we would be left with z and y, or we could plug it in here, but we would be left with x, y, and z. So we want to plug it in to the next equation that we know the most stuff about, which is this one. So if we plug in this 8 in there, we're going to get 4z is equal to 6 times 8, right? Just plug it in, plus 8. So this is going to be 4z is equal to 48 plus 8. 4z is equal to 56. Z is equal to 14. You can use a calculator, don't worry. So now we have two variables, right? We have w and z. So this equation, check. We know everything here. This equation, check. We know everything there as well. And now we can solve for this y, right? Because we've gotten everything else. We have this z, we know what it is, and we have the w, we also know what it is, meaning we can isolate this y. So y is equal to 6 times whatever you said z was, 14, minus 9 times w, which is 72. When you plug this into the calculator, which I'm not going to do right now, we get y is equal to 12. Okie doke. And now we can solve this final thing for the missing variable, which is x. We have y now, we have z, and we have w. So I'm just going to show you how to do that. So we're going to have 8x plus y, which is 12, minus 20 times z, which is 14, plus 10 times w, which is 8, is equal to 20. Now, what we can do is move everything other than this 8x over to that side, and we're just going to solve for the variable. So 8x, and I'm not actually going to really do that much arithmetic because I'm sure you guys could, plug it into the calculator, is equal to 20 minus 12 plus 20 times 14, which is 280, plus 80. You divide everything by x, and whatever you get here, divide everything by 8, and once you do that, you get x is equal to 26. So we just took this whole big long thing, right, and then simplified it. And you always start out with what you know the most. You never try to figure it out starting with this, because there's no way, you don't know enough. But once you start small and then keep building up, you can eventually solve the whole rest of the thing. So don't get scared whenever something like this comes up. Just calmly think to yourself, okay, what do we know, what do we have, and what do we want to try to figure out? And how can we use what we have to get there? And you can really do that with any kind of problem. That's kind of how the problems of this world are solved. So yeah, don't panic and just think about what you do know.